Recording. Probably turn down my mic a little bit. It's sort of loud. Okay.
Oh,
Yep.
sorry. I don't want to like interrupt your thing, but uh, do you mind like introducing who you are?
Oh, sure. Yeah. So my name is Joe. I go by my good sir, and I'm uh currently a CS major at Towson University in Maryland. I'm focused on computer graphics and game engine design, and my goal with doing this workshop was to get information about C family languages out there in this space, so that hopefully later I can do a computer graphics workshop because I'm super passionate about that.
Yeah.
And
Yes, yes, yes.
yeah,
I want that. Yes, please.
so most of what I do right now is computer graphics, and so a lot of shader languages. They're written in like C syntax, and um, you most of the time when you're trying to write something like a game engine or something like that, you'll use C or C++ because it allows you to do uh, memory management rather than having the language do the memory management for you, and that's really important for performance, especially on a GPU where you've got high memory latency but also really high memory bandwidth. So you want to do parallel processing and stuff like that. And cache misses are super expensive. I went over a lot of that in the first session, though.
I have another question if you don't mind me. Please, first of all, pleased to meet you, Mr. Joe. Um, and secondly, so what we can this lesson can provide us is we like there is a part of like gaming think programming related, right?
Mhm.
I
Yeah.
think,
Uh,
can I?
Yeah.
I think the idea is and I don't know how much you know about it. You sound like you don't know too much about it, but I'm sure you know the basics. Any kind of software is written in a language. C++ in this case is just a language, and so if you learn how to speak it, then you can use it to make something. So I think his idea is to like teach you to speak the language of C++.
yeah, because thank you. Because I already attended the workshop that was about Python language,
Hmm.
and it was very much advanced for me. But yeah, thank you, Skull, and thank you, Joe. You can guys go ahead. Sorry to interrupt you again.
No, no problem. I did want to uh, at the beginning of this session sort of recap a few of the things that I covered in the last one. So, first one, um, we're using Replit, and I'm going to post the link to this repo in the resources channel after the session as well. So you'll be able to use the code that's there and mess around with it, stuff like that. And uh, in C++, you have header files and CPP files. And so header files are meant for being able to do forward declaration, which is something that the compiler needs because it doesn't. Uh, it, it's something the compiler needs for linking. Um, and I covered a lot of that in the other things, so I'm just gonna kind of skip over the details. You've got different data types for when you're declaring variables. So um, if you're declaring a variable that's like an integer, you have to write int first, and then your vari- variable name, right? You don't have to, um, yeah, uh, you don't have to define it every when you declare it, but You need to define it before you use it. When one thing that differs from Python is at the end of the line you need a semicolon. So in Python, you could just say like, right, and then you can just keep going. But in C++, and that's gonna make this variable. It's gonna set it to the value 10. In C++, you need to say int, which means that this variable is going to be an integer. And then you say it's equal to 10. And then you put a semicolon at the end of the line so that it says, okay, I'm done with this statement. I think I forgot to mention that last time, and I felt a little bit bad about that. Also, function syntax for C++, you have to state the return type. So you'll say like, well, if I go into main.cpp, because we're going to need to do this, int main parentheses, and then these squiggly brackets. The curly braces are there because in between curly braces defines a scope, and a scope is kind of like a place in code where all of the variables retain their definitions. So if I define variable equals 10 right here, and I say if I wanted to like print the variable, which this isn't, this isn't proper syntax, but right, this doesn't work because this variable isn't defined here. It's only defined inside of these curly braces. I would have to bring this down here, and then it would work. This in the parentheses here, this is the parameter list. So you could say int arg, right? And that takes an integer argument, or you say like, oops, it's just bool and C++. Yeah, bool arg, so it's a boolean argument, or you know, and that's a C string argument. C strings are just character arrays, which Charstar is actually a character pointer. Arrays are stored as a list of values that are contiguous in memory, right? And so if you pass in the pointer to the first value, the pointer to the memory location of the first value of that array, that's essentially the same thing as passing in the array. What else? Oh, it's I forgot the so this is how you import this is the same as like import in Python, so that's how you get standard library like packages and files and code, stuff like that. That's how you link your code together as well. So if I wanted to then this will include the code that's in here and here. And it functions the same as like just copy and pasting the code into the same file. So yeah, I think that is good for now, for like the recap. And
Return 0?
you don't actually have to return 0 in main. No? No. So main is the only function that the compilers don't care about returning from. It's just going to implicitly return 0 at the end. But normally you would want to return 0 in a function with int, right? Because you have to return something, unless it's void.
It's generally my understanding that some people maintain the practice of keeping return 0 at the end of int main to keep their sanity, because it's nice to know exactly when things are ending. You return 0 because then you can see it returning 0. But yeah, like you said, you don't need it there. I personally put it there myself because I like seeing it. It makes it finishes the idea of what a program is in my head.
Right.
But yeah. So you can put it there. It does the same thing.
Yeah. I mean, I usually do as well. Void main isn't valid in C++, I don't think. Okay. Void main in Java and like some other languages, that's how they have the main function as a return type of void. I think in C++ you have to return int.
Because you need to return a 0 for the program is works, and then anything that's not 0 means it failed.
Right. And it looks for the specific function signature, I believe, as the entry point. Right. So I think we can sort of get started. I'm gonna start with. I've got this set up here so that we have fruit and a basket, and we're going to store fruit in the basket, and we'll have different types of fruit that we can store in that basket. And I think that's pretty good for object-oriented stuff, just kind of to begin. So got our header guard. Don't forget that. It's pretty important. Because we're actually going to need to include fruit.h in both basket and main, and basket's going to be included in main, so it would get included twice. And we're defining a class in here, so without this header guard, our program will not compile at the end of this. So I'm going to make a fruit class. The fruit class, it's going to have integers, and firstly, these are going to be the private fields. So you do private : and then below that is the private fields. Class members are private by default, so I don't actually need this here, but it's nice to keep things explicit. It makes things easier to read. I'm going to start with integers m_age. So this is a convention thing. Private member variables normally start with m_. It doesn't have to. It just makes other people read your code more easily. And m_ shelf life. So we're gonna have how many days old the fruit is since it's been picked and put in the basket, and then we're gonna have how many days it says before it is rotten. And we'll have a float m_. ripeness. And I think that's all we have to really do for private variables. Then we'll do protected. So protected variables. This access level is for it can only be accessed by the class or any direct children of the class. So if we make a subclass for fruit, like say apple, which we will be doing, that apple will be able to access these members, but apple will not be able to access age or shelf life or ripeness, because only fruit can access these.
Are we gonna be making fruit an abstract class or like an actual class?
No, it's gonna be an actual class. We'll need to because we'll want to be able to instantiate it for when we try and do like polymorphism in the basket.
Right. So we're not gonna add the well, virtual functions to it.
No.
No.
I'll talk about actually yes. Yes, we will have virtual functions in this. But it's not going to be a purely abstract class, and they won't be pure virtual functions. I think I have this code pre-written because I wanted to make sure that this went smoothly. What did I have for the fruits update function? Right. I guess the fruits update function actually might be pure virtual function. Anyway, but yeah, there is a virtual function in fruit. So let's see. So protected members are accessible by children, but not anything else. So children and the original class. So
by children, do you mean inherited classes?
Yeah, classes that inherit from fruit.
Okay.
Also,
hi.
Hi.
Yeah, I don't know what you did last time, but I know there are new people here, including me. I already know this, but at least one person was new. Did you actually address the idea of like what inheritance is and like
I did say
hierarchy and stuff?
I did say that I did say that there were some prerequisites for this course, right? And that the workshop would assume that you would know some basic programming knowledge, that you would assume that you had taken like an introductory course to programming, and in most introductory courses they go over the basics of object-oriented design. So we'll start with void set age, right? Just in case we need to set the age outside of updating, right? We'll take in, an integer age. Which, by the way, these, so this is how you forward declare a function. This will be a function when we write it in fruit.cpp, but we're not defining the body of the function yet. We're just defining the function signature so that the linker knows that it exists for when we include this in other places. You don't need to put age there. You can actually just put the return type of the variable. I like to put the name of the variable there because I think it makes the code more readable. I probably shouldn't be calling these functions. I should probably be calling these methods. So now we're going to do a virtual function that returns void called update. And so this is a pure virtual function. It will not be defined for the fruit class. Actually, that's going to give us problems in instantiation. I think what we're going to do is we're just going to give it an empty body. Which will work for us. The reason you want to tag this function as virtual, right, is because you want for when you define a fruit object and then you store, like, say, an apple object inside of that fruit variable, right? You want, when you call update, you want the apple's update function to be called, not the fruit's update function. Does that make sense?
Yeah, makes sense.
Did you say that the fruit won't even have an update function?
The fruit will. So this isn't a pure virtual function. This update function just has a body, but it's empty.
Okay.
So the reason we're calling this virtual is because if we have an object of, or if we have like a fruit variable, but we want to store an apple object inside of it, we want the apple object's update function to be called rather than the fruit object function, or update function.
Oh, okay. And if we didn't declare it, then it would take the fruits function. Is that
Yes. So it's just saying virtual means that it's expected to be overloaded. Then we'll have a void set ripeness and ripeness. Okay. And we can do public. These will be the public members. Public members are accessible by everything.
Sorry, is there a way you could scale up the code a little bit?
Oh, yeah, I can do that. Is that good?
Oh, that's better, yeah, thanks.
Okay. Might be able to move this over and then...
Yeah, that's great.
Alright, and then public and get age. We need to check the age of fruit. And get shelf life. From we need to check the shelf life of the fruit. Float. Get ripeness. We need to know how ripe the fruit is, and bool is rotten. We need to know if it's rotten or not. Then we'll have the constructors. So fruit and age and shelf life float ripeness and a default constructor that takes no arguments. And at the end of a class, you have to put a semicolon, a class definition. So this is the entire fruit class 4 declared. We haven't found any of the functions yet. And there are some functions in here that, or there are some methods in here that will be common across all fruit. Like, is it rotten? All you have to do is check the ripeness against, or sorry, the shelf life against the age, right? So we've got that stuff. And while we're in here, I'm not going to bother with making new class files. Instead, we'll have the child classes declared in the fruit header file. So class apple inherits public fruit. So that's access specification of the inherited class, and we'll have in here, maybe I should keep this consistent. So we'll have a constructor, we'll have an overridden update function, and that's really all we're going to do for the apple class. And then we'll do the same thing, but make it a banana. But this time, we'll have the ripeness change based on a rate for the banana, because bananas ripen faster than some other fruit, right? So this shows you some of the freedoms that you can have in extending classes like that, right? Any questions before we move on?
Wait, aren't the classes already have the start off as private, so there's no need to say private?
Yes, that is correct. As I said, class members are private by default, but I like to do this because it is more explicit. It just makes it easier to read. If you said struct, then those are public by default. So all of this would still be valid, because the only difference between structs and classes are that classes are private by default and structs are not. So
Question.
Is
yes.
That is that the same thing for a what's it called, a union? Is that the same for a union?
I'm not sure.
No. Okay.
Unions aren't structures, they're more like combining types inside of the same memory location. So
So-
here, in a union, those access specifiers wouldn't work at all.
Well, okay.
Can you guys hear me? I don't know if you guys can hear me.
Yeah, I can do.
Yeah, we got
Alright, so does any kind of business logic go inside of an H file?
You can write the logic in here. If you wanted to, you could write the entire class definition in here, and all of it. But normally, you just forward declare things in here.
Wait, so,
Go ahead.
so the reason that you're not defining the update class, not class, the update method, is because it is in an H file and you're going to define it later on the main?
I'm going to define it in the CPP file. So
It's a CPP file.
yes. So the H file is header files are what you use for basically for linking, right? It just shows all of the definitions and all of this stuff so that when you include this H file in a different, like a CPP file, all of those the compiler can be like, okay, these functions will exist in the program, I just gotta find them. So we're going to assume that these are legal, and then it'll look for them, and then yeah.
So the CPP file is sort of like the equivalent of the .c file in C.
Yes, absolutely.
Okay.
And H a lot of people actually, when if you're writing a program that has both CPP file or has both C++ and C code in it, you'll see that a lot of people, instead of using .h for C++ code, they'll use .hpp.
Big brain.
Yeah.
That's great.
Um,
Alright, so are we going to define the update function next, or what's the plan?
yeah. So we're gonna define all of this stuff in the fruit.cpp.
One quick
Great.
question.
Yep.
If I may. In the class declaration, you wrote class apple public fruit. What's the purpose of the public keyword there? I assume
So-
it just means that apple inherits from fruit, right? But
Yes. So that's the axis, like. Sorry. Is someone gonna speak?
I don't think so.
Okay, I heard. Maybe my computer made a noise. So that's the axis of the inherited members of the fruit class, right? So, the way that I understand it is that if you inherit fruit publicly, then these public members still inherit as public. The protected members still inherit as protected, and private members still inherit as private. But if you inherit it as protected, then these public members get inherited as protected. Right?
Right, gotcha.
Um, okay, so when we're defining functions for so we're including fruit.h, which that's important because that's where we declared everything. Now we need to define it. So when we're defining things, I like to kind of separate my code with the comments like this. I'll have like private variables or private members, sorry, and void fruit, and this is the scope resolution operator. So, then the scope of the class fruit, and then the function set age, int age, and we can have wait, this isn't private, was it? Set age was protected. I put this as private. Huh. So anything in between these brackets is a scope, right? So you can have it all on the same line. You can have it extended between multiple lines. Doesn't really matter. If you want to make things compact, you can do this. If it's a one line thing, then it's not all that bad. But you want to be careful because this can make your code really unreadable. Double check for age. Is this?
Can I get the code for the class for banana? I wasn't able to copy it fast enough.
This?
Yeah.
Yeah. We're gonna define all of the stuff for all of the classes in here. This is what we're doing the whole session. So it's all gonna be object oriented this time. And then after, I think next session I'm planning on doing templates and generics and a little bit of metaprogramming if I can get my knowledge really ironed out about that stuff, because I don't use them super often, so they're still like a little bit nebulous to me. In some respects. Wait, what was it? All right, so. I'm going to copy and paste this because it's basically the same thing. What did I... Yeah, I did make it bold. Okay. So then for is rotten. All we have to do is return age is more than shelf life. And then set ripeness. And then, okay, important one. So, constructor. Fruit. Constructor, you don't specify return type. Int age. Int shelf life, load ripeness, and then now we'll do member initialization list. Oops. And then I'm gonna do you don't need to line things up in your code like this.
Ooh, I'm mega lost.
Okay, yeah, I'm gonna explain this in just a sec. Okay, so I'm just lining these up because I couldn't really put them all on this line, and because they're not actually part of the function body. So what this is doing is it's initializing these member variables. These
Those are fields, right, from a class.
yeah. So these are from the fruit class, and it's saying that this integer age that's passed in as a parameter is what you initialize this member as.
Okay.
This shelf life is what you initialize this as. And then, yeah. So this
So,
is just, yep, go ahead.
This notation I've never seen before. The fruit colon fruit. It's like everywhere on this file, and I don't know what it means.
Okay, so this is a scope resolution operator. So this
What a big fancy thing.
the fruit scope is just the class fruit, right? So we're saying that this void function of set age that is in the fruit scope, right?
Okay.
Is this function body. So we're just defining the
Okay, so
function body.
You're defining a function. Or
Yep.
A method.
In the main here, right? In a simple hello world application, right? You've got you've got this. STD is the standard library scope. Cout is console output. This bit shift left operator is essentially the same thing as saying .print. And you're just pushing this into the console output. And then you're pushing this further into the console output, like after this, right? And this is just the end line in the standard library, right? This. Go ahead.
Yeah. Could you go back to the basket then? Let me see if I understood what you said. Oh yeah, to the fruit CTP. Okay. So where it says void fruit set age, that weird notation says, hey bruh, look in the fruit class. Inside of the fruit class, there's a method called set age. And this is what that method is going to do.
Exactly.
Alright, good. So it's a really strange way of defining a method. I've never seen it before.
So if you want to, every time you want to call a static method, right? This is if you want to do like let's say that set age was static, right? And you were inside of a function here, and you wanted to be like fruit whoops. You could do that, right? So you wouldn't be able. So you're not like instantiating an object just to access a static method. You can also do this if you just do right, and then you declare a method in here. Whatever, and then you call it out here as
Oh, okay. So the double colon is like the the dot in C and Java.
yes, it's very similar. There is still a dot operator. I don't know why this is mad at
You
me.
can you can also with the namespace use you can also say using namespace of the namespace, so then you don't have to keep on saying the namespace colon
Right.
the function.
Yeah, so you can do that. The only reason you might not want to do using namespace, right? Because if you go up here, and a lot of people in their first Hello World programs will do. Right, and then you don't have to do this scope resolution because it'll basically say, all right, all of this stuff, this is in the assume it's like in the STD scope, or it's using functions for the STD scope. The reason you might not want to do that is if you've got cout, like if you've got a function right called cout that's defined somewhere in your code or in your namespace, then there will be like a scope conflict thing. Yeah. But other than that, I think it's perfectly fine to do this because chances are you're not gonna have a function called cout in your code. Just be like aware of it.
Alright, great, thank you.
Yeah.
That was a great explanation, by the way.
Yeah, I'm glad it helped. Some of this stuff can be like, it can hurt your brain because it wants to be like explicit and structured, and it deals with a lot of like specific or complicated concepts, but I think it's intuitive once you get it down.
Can I ask about one thing? You know how in your set brightness method, you put int brightness while like the other brightness is float.
Oh, it should be float. Thank you. And here's it. Why did I put this like this? Ah.
Learning C++ is like learning D&D.
Yeah, like you just keep learning.
And it never stops.
And it never stops. Yeah. And then you get excited by like a new feature, a new thing that you learned about, and then you want to use that everywhere, even when it's not all that useful or easy to read. Because there's some pretty cool stuff you can do, and it's neat. Then then for the normal fruit constructor, I'm just gonna. Why are you doing this to me? Can you don't? Okay. All right. So here we're just setting these things. just look at something real quick. Why did I do it this way? It was probably breaking something if I did it the other way. Yeah. Unlucky. Okay. Neat. So we're done with defining everything in the fruit class. The fruit class is complete. We did it. We have a class. Now we're going to make an apple. So set age was protected, but the rest of it's public. Yeah, I don't want to do this. I'm just going to say now. For the apple class, we'll first start off by writing apple update function. Hijack iPhone break text messaging. It's a bad attempt at a joke. Unlucky. For the update function, we're gonna do set age as get age plus 1, and if not is rotten, remember in here, inside of this, right, this scope is within the scope of the apple class. So we can say is rotten without even referencing this apple class, and it's going to say, okay, this is rotten for this apple object, not for the fruit thing up here or anything like that. It's just for this. It's not for the banana is rotten, because that banana is rotten, you know, or oops. Or like the set age for anything else. Like if we had a like a ham sandwich class defined in here, and it had an is rotten thing that was completely different than the fruit is rotten and wasn't inherited by any of the fruit. This is rotten. It's not going to get mad at us. It's going to know it's meant for this apple class. Same for this get age and this set age. It's essentially like saying this dot implicitly. By the way, this is a thing. This is a thing. Which just means this is just a pointer to the object that owns the function that you're calling. Yep. Let's do the scope. If it's not rotten, then we do the set ripeness like get ripeness right. Oh, I'm writing this as the. I'm dumb. Okay. This is different. Okay. This is what I was doing for the banana class. For if not is right. Okay. So inside of this update function, we're updating both ripeness and age, right? So the amount that I'm changing the ripeness by, get ripeness, and then divided by days. Whoops, days left. Whoops. Okay. And set ripeness. Get ripeness plus delta. That's not all that important, but yeah, I'm just like you can update the ripeness, you update the age, so you just increment the days that existed by 1, and you can do that stuff, and then another constructor if init. Oh yeah, I spelled that right. And here we've got another initialization list, but this time it's actually just calling the super class constructor, right? So it just immediately it's calling the fruit class constructor, and it's like, do the age is 0. It starts out at 0 days old once you pick it. Makes sense. 14 days for shelf life. I think that's reasonable for an apple. And then initial ripeness, we're passing that in because when we pick it, that's when we decide what the ripeness is, right? You inspect the apple, you're like, okay, it's pretty ripe. And then you put it in your basket. So if it's ripe enough. So that's how you do that. That's how you call the super constructor. In Java, it's just super, right? But that's not how it works in C++. Now we'll do the banana class. Yeah, we'll check that things are still recording. Yep, it's still recording. Cool. Wow, I've been doing this for an hour. I hope I'm not too boring. So, yeah, void. Well, I'm just going to copy this because it's basically the same concept as last time. You do the update function for the banana. And then for the banana constructor, we have banana, float in it. And and I had this as like 9 days. Bananas rot pretty quickly, or they get, I don't know, they get like squishy and brown. Like they're probably still safe to eat. Like you could put them in like banana bread.
Brown are the best.
Yeah. And then and then so we had a ripen rate variable in here, right? That we had that we're gonna set to 0.0 minus initial ripeness, and then divide that by 9. So this is just saying that it ripens at a linear rate, whereas with the apple, it ripens more quickly immediately after you pick it until, like, I think that's how that was working. Unless I'm dumb. No. I don't know. They ripen differently. It's not important.
The apple ripens linearly. The way
Yeah.
you've defined it here.
I might just be dumb. But my math isn't what's important right now. I guess so. And I wasn't thinking too hard about this stuff, so yeah, so well, like that's everything. That's all of the fruit classes there. And now we'll move on to the basket. And I'm only making this a header file because I was too lazy to also do a CPP file for this. But it's not much, and at the moment I have well, let's just start. We need to include fruit.h, and then I'm gonna skip this first part for now. So we'll just say class basket. Private. We'll have an array of contents. And this should. Why didn't I put this? And I think we want to store the material of this basket, right? So let's make an enum material. And now we could say fabric, straw, wood, plastic. Sounds good. Forget the semicolon at the end. And now, down here, we can do material, mat. m underscore map. So we'll start off with our constructor. Constant size. And then m underscore capacity. Equals size, and then m underscore count 0, and then we'll have m content equals new fruit size. This is why we need a default constructor, and why it couldn't be a pure virtual class or an abstract class. Sorry. So we need to populate it with fruit objects. Allocate space for them. So there's a constructor. That's cool. But what you haven't seen yet, that's also cool, is the destructor. So we need a destructor for this class. Why do we need a destructor for this class? Because this gets allocated on the heap. This is heap allocated memory, and it's referenced to a pointer, and that's dope. But the problem is when this pointer gets passed around, like, you don't know where it is. You don't know when you need to clean it up. You don't know when it goes out of scope. So automatic garbage collection's not gonna worry about it, which means that when you don't need it, the memory's not gonna get automatically deallocated, and you're gonna have a memory leak. You're gonna have memory that's being refused to be allocated to, and refuses to be cleared, but it's not being accessed by anything. So you need to free that memory, and you do that with the word delete. And when it's an array, you do this. And that's all you have to do. It's pretty simple.
How do you know when you need a structure?
When you do something like this. When you use the new keyword, that allocates memory on the heap.
So when you create objects,
Yes.
is a pointer an object?
Anytime you do this, yeah, it's like, so, yeah, when you dynamically allocate memory
it's
like that.
mostly for dynamic allocation. Because the program doesn't know that you want to deallocate the fruits, for example. You could be holding references elsewhere.
Yeah. Because when you do this, like, whoops, don't do that. Let me check my main function over here. Yeah. So there's going to be a get contents function in this that's going to return this array, and that's going to get passed to the main function when I call it from the main function. So when you do stuff like that, like, and you store that in a variable, you're storing those pointers, which are basically memory locations, And so if you deleted this whatever basket object, right? But you still needed the data that was in those memory locations for the contents of the array, then if it deleted the contents of that array, you wouldn't have the information in those memory locations because it would be wiping everything from the memory of this like basket class, right? Once normally one like let's go to here for example, right? So this days left variable, once the program hits this curly brace, this gets freed
Okay.
because it's now out of scope. But with pointers, you can pass them from scope to scope. You need to be able to pass them from scope to scope. So it can't do that on its own.
Ooh. The pointers need to be destroyed or freed manually.
Yes. Yes. Well, pointers that are dynamically allocated need to be destroyed. So it's different if you do something like if I did int star dlptr, right? Like days left pointer equals and you do and days left. Am I doing that right? I think so. Okay. If you do this, that memory still gets freed because this wasn't like dynamically allocated. This is a variable that was created on the stack and exists on the stack, and it gets freed from the stack. And so this the value at this pointer is going to get like, and the pointer is going to get freed and shit. So that's cool. But the new keyword makes it dynamic allocation.
So I need to say new. Is there any instance in which I need to destroy something without saying new?
No.
Okay, then that's great. Yeah, we can continue.
Yeah.
Yeah, this can
Okay.
be a bit confusing.
Yeah, it can be.
Thank you.
What was I doing? Basket.h. Okay. This is good. This is important because this is the kind of make or break thing in C++. If you're trying to use it for like, if you're trying to use C++ for what you should be trying to use C++ for, which is like things that you want to optimize. Like if you're running a program that doesn't need to be super runtime optimized, don't use C++. Use something easier. Like I don't know. I'll write something in Python before I write something in C++ if I can, like if it doesn't need to be super optimal. But and if you're not like doing like memory allocation and stuff like that, like sometimes you just don't need C++ and it's just too verbose and it's annoying. If you like it, by all means, just use it. But this is important because I think this is one of the, since memory allocation is so important in C++ and why one of the reasons, if not the main reason, why C++ is so widely used and so useful. Because of that, you need to know how to free the memory. Otherwise, your C++ code, your shitty C++ code, is going to be way slower than shitty Python code. So, like, you've got that trade-off. Like, you want to try and make sure you're being careful in C++ because you can make mistakes that are big oopsies. it gives you that freedom. Same thing goes for like you can use pointers to write past their allocated memory and stuff like that, and do like overflow errors and stuff like that. Like, and that'll write into memory of other applications, and that can crash things. So when you're playing with,
Weird, dumb question.
yeah, go ahead.
When is C++ faster than Python?
C++ is faster than Python when you're dealing with large data sets that you want to well, first of all, Python has global interpreter lock, so it can only run on one thread. So if you want to do multi-threading, you have to be using something other than Python.
No, I didn't even know that.
Yeah, but that's because it's an interpreted language. There are tons of libraries for C++, for Python that are written in C++ or C, and then you can just like kind of hook into them or whatever. Like I think like SciPy or what, there are a bunch of them. I'm sure some of the ML stuff like TensorFlow and stuff like that. But when you're dealing with data, the biggest performance, like runtime performance bottleneck you're going to run into is data management, because memory is slow compared to the other advances in hardware that we've had over the past few decades. Memory has lagged behind quite significantly. And so when you're processing data, you want to be processing as much relevant data at the same time as possible. You don't want to send useless data, to your CPU cache, because things go in, like data goes in certain like 128-bit chunks, stuff like that, right? The reason for that is if you're only trying to process 32 or 64 bits of that data, all of that other stuff that's next to that data in memory that gets passed there is useless, and then the rest of the stuff that you have to process still needs to be found in memory and then sent to the CPU. And while it's looking for that data, especially if it doesn't have all of the data to do the calculation, then the CPU runs idle for an amount of time, and it'll be like 200 cycles. Like, it's a significant amount of time wasted. And that's what a cache miss is, or a cache miss. It's a cache. Yeah. And you want to get and that's even more expensive on GPUs. So that's what you want to use C++.
Can I
That's
add
what I
to that
use.
answer?
Yeah.
So the reason why C++ can be faster than Python is that in C++ you have the control for how your memory is going to be allocated. So you can go into more detail, and you can make sure that no like allocation is wasted. So like if you're programming Python, like you're going to be using libraries, and you can't allocate the memory manually. So it's not going to be the most optimized all the time. But if you're programming C++, you can like allocate the memory the way you want it and the way it's efficient for your program.
It's
Okay, so what
probably.
I'm listening, someone else wanted to say something?
Oh no, I was just saying that was probably easier to understand.
Okay, so what I got from this is that um, C++ gives you the freedom to tap into your memory and modify it as best as you want, at the cost of being incredibly verbose, and but also it also gives you a lot of efficiency,
Yes.
right?
Yeah.
And
Yeah.
Python is just more readable, easier to write, kind of for dummies. And I'm a dummy, so I mostly use Java, but I'm a dummy, so I like Python.
I mean, Java. So Java is arguably just as verbose as Python, and in some ways, in some ways, it being verbose is a good thing. Java is really good at holding your hand and like barring you from doing anything stupid. It tries its best. It tries its best to prevent you from breaking stuff. And I can respect that about Java. Like for instance, Java generics, the the things that you get like that, right? And you have like something like that.
Yeah.
Those types are that those are type checked, right? So they're type safe. Whereas with C++, templates are a lot more like macros or preprocessor statements and stuff like that. So they are much more powerful, but at the same time, a lot easier to break. So there's some give and take, and every language has its own sets of upsides and downsides.
The C++ is for big boys, and Python is for not so much big boys.
Humorous.
There are a lot of like the majority of AI development that I know of is done in Python, but I think a lot of that is because first of all, Python has really good libraries for that stuff. So it's almost like a waste to go with anything else. But the other thing is that people who are working on AI want to think about the problems they're having with the AI, not the bugs in their code or how to optimize their code. Like that's not what they're there for. They're there for figuring out how to teach computers how to think. So like the less they have to worry about their syntax and the optimization of their code and stuff like that, and they can just kind of structure the thing that they want to structure, the better. Then they can work more efficiently and solve things better. So it just depends on the thing that you're trying to do. This basket class is almost finished. I'm gonna real quick write the there's void add fruit f, and then that's not what I wanted. And then plus, and then All right, and that's it. I'm going to add a list of to-do things here. We have last time I didn't give you guys any challenges or like if you guys any anything to try and work on to see if you can figure stuff out for yourself. So I put a little list together of some things that you might want to try and do to make sure you have like a decent understanding of how object-oriented programming works in C++. And just as little like puzzles, brain teasers, or whatever. It's not a lot. For some, it might be a little bit difficult for others, but I would encourage any of you who think that you'd get something out of trying to do this to give it a shot. And I'm gonna link the Replit repo. I need to. I wonder if I can. I don't want anybody to accidentally like change the code that's in this repo. Because I know you can do that on Replit. I don't know. I'll just I'll trust you all to try and like not break anything. Here, please. Try. And the code's in the video anyway, so hopefully like if anything does break then you know, whatever, or just DM me. So I have all of this code in a local like Visual Studio solution written exactly the same way. So if you need me to copy and paste anything, just hit me up in a DM. Last thing first to do. What's up?
I was gonna say, I noticed you put content so in underscore content. Is that
Wait. Basket.
the last thing the return contents and contents.
Oh, my bad.
Just in case I was making it really good one.
Thank you. That was important.
And above it now, put it on.
Yeah. I
One
have.
line below that, you're missing an N count. Line 26.
Typos everywhere. Thank you. Let's see. Int main. We've got this basket.h, and we've got to include. So here we're gonna create a new basket B set equal to basket 5. It'll have it'll be able to store 5 fruit in it. Say B dot add fruit, and we'll create a new apple. That would be 0.5 f. Remember, when you're writing float values, you put an f on the end. Otherwise, that's a double. Oh, it made this capital for some reason. That wasn't consistent. Oh, that's not where I want the semicolon. And then in cout, we'll just print this shelf life. So because it's an apple, shelf life should be 14 days. If we look back at our fruit CPP, 14 for apple. So if we run this and it got mad at me, why did it get mad at me? Let's see. Okay, error. Declaration specifiers. Okay, let me. CPP1. Let's look. And 934. Let's say. Let's run it so that I can read this. Okay. Fruit.h. Oh.
It's supposed to be banana.
Okay, and that's that same error, and then. Right, okay, so. Yep, there we go. That was the only thing we had a problem with. So 14, which is what we expected it to print out. So there we go. We're good. So that's object-oriented programming in C++. You've got this basket. I forgot to talk about this. So basket, you've got an array of fruit, right? And when you're adding a fruit, it's taking in a fruit, it's something of type fruit, and adding it to contents. But in main, we're passing in an apple, which is of type fruit. But that's important because then we're getting back like the correct value, right? It was still able to hold the object that was created of type apple in a fruit. In an array of fruit. And it created the object correctly. So that's neat. It was a success. We did it. Are there any questions that you guys have right now?
Oh, nah, I don't. Um, I learned a lot of things. I didn't know anything about C++. Pretty cool.
I'm glad. If you guys do end up if you guys do end up having any questions, feel free to shoot me a DM anytime. I'll try and answer it to the best of my ability. Remember that in this basket.h, there is a to-do thing. I strongly suggest you guys open your own Replit thing and or like fork this one and implement these things if you think it will help you. I'll also put this in the projects section here, and I'll put this Replit repo in I think I'll put it in projects as well. I think I'll just put the repo in projects. And like these bullet points for the to-do list, and then if you guys want to implement that or whatever, just whenever you're done, toss it into the project submissions, and I'll give you any feedback that I can. I think that's all I had for today. Is there anything that any of you want to discuss before we wrap up?
I'm thinking. I can only think of stupid things that are completely unrelated to the workshop. So yeah, probably not. I was like, how do you get a girlfriend? Yeah, I don't think that we have the answers to that.
What was that question?
How do you get a girlfriend?
Oh yeah, that's
But yeah, that's completely unrelated to the workshop. So sure.
that's a good question, dude.
That is quite a good question, right? It may be simpler than C++.
I think you might want to look more into AI research. That could help you out. There are great
How about
strides being
psychology?
made. That sounds manipulative. I don't know if I want to use that to get a girlfriend. I'm gonna try my best to just live for me for now.
I mean, you can use psychology to find your scars and be like, hey, let's get better at that. And then maybe when you get better, you can get a girlfriend. But anyway, who cares about this? Alright, is this the end of the workshop? Are we doing something else?
No, this is all I have planned for today. I'm just I'm here for if anybody has any questions.
I have one, which is why understanding your naming convention for the M underscore.
Oh, you want to understand why it's M underscore?
Yes.
So these are member variable. I understand it as member underscore, right? So M underscore is for private members, right? That naming convention, I don't know where it came from, but that's just what I've seen, is that private members are denoted with M underscore.
Yeah, thanks a lot for the session, mate. Where are you posting or have you already posted the link?
I will post this repo link right now in projects here, and the to do. So there's that. Try not to like delete any of the code or whatever. I think that Replit just allows you to write permissions in this
Oh,
thing.
hey.
So
When is the next workshop?
next workshop should be. Let me look at it. Next Saturday is the 4th. So I think it'll probably just be next Saturday. Same time, like 3.
Perfect.
I'll make an announcement in the workshop schedule.
So if I click fork up top, is that me going into my own branch, like not destroying anything that anyone else has done?
Yes, that's what it should. It should fork it to your own
Cool.
repo.
Just making sure that I'm not
Yeah.
messing everyone's files up. Sure.
And again, if anything does happen to the repo, it's no big deal. I've got all of this stuff in Visual Studio right here, written the exact same way, and even the to-do list. So anybody needs that stuff in the future, I've got it. Yeah, but I think that's all for today.
Alright, dude. You did great, by the way.
Thank you.
You're pretty good in structure, and thank you for all the. Thank you for for making the workshop, because these things take so much time to plan, and it's really difficult to be in front of a class and code at the same time and not panic. And so that's why I said that you did great. So,
Yeah,
thank you, man.
I've got excuses lined up for how slowly I type, so I'm prepared.
Beautiful, man. All right, I'll see you guys next workshop.
All right, later.
See you guys around.
Later.
Bye, guys. Video will be up on YouTube, by the way. So
Noise.
on